Welcome to Statistics Vocab. We're specifically going to focus in on the difference between populations and samples today. So Dr. Pompilio gave all students at Central High School a survey to fill out regarding their favorite subject, which we all know is math, right? Anyway, Dr. Pompilio then randomly selected 3 classes surveys to review. Identify the sample and the population in the given scenario. Now, even though you don't have the definitions of these given, based on what you already know about population and sample, what can you tell me? So we know that sample is usually a small group from the population, right? Because the population includes everyone. So in this case, I'm going to say it's the big group. So you have 2 different groups going on here, right? You have that he gave all students at Central High School, everyone, and then he only chose 3 classes to actually review. So you have the big and the small. We can say that the population is students at Central High School. Oops. Whereas the sample would be the 3 classes. So it seems like an easy subject, right? And it is, but sometimes the difference between sample and population is a little more tricky, I guess, to spot. So let's look at the actual definitions. A population is the entire group of subjects that we are interested in obtaining information about. So usually the keywords are all, because all usually means everyone, the entirety. Now, a sample is a smaller part, right? S for sample, it's a smaller part of the population from which information or data is gathered in order to generalize about the population of interest, right? That's the whole idea of statistics. You take the population that you're looking at, right? And you ask a small sample of people, because let's say you're talking about Central High School, for example. There's a lot of people in Central High School if you were going to take a survey. So instead of asking everyone, we ask only a sample of them. That way, we don't have to do as much work, right? Because sometimes it's not realistic to go around and asking every single person for their opinion. So we ask a subset, a sample of people, and then based on what the sample says, we try to make a generalization of what the population would think. Now, let's try actually practicing if we can identify if we're talking about a population or a sample. Now, if I were you, I would look at the PDF of this document that goes along with the video. I would read through practice questions A through E and decide population or sample, and then come back to the video to see if you got it right or not. So for the first one, you obtain a list of all the students at Central High School. Now, is that a population or a sample? I said that it's a population because it has all of the students at Central. And remember, population is if you're talking about the entire group. Now, this also depends on how you're looking at it, because it can also be a sample. If you're saying that it isn't all of the students in the Valley Stream district, right? Because there's Central, there's South, and there's North. There's also Memorial. So it depends on how you actually tend to look at it if you're talking about a population or a sample, and a lot of these can be argued to be both. For the second one, you pick every fifth person who enters the school to answer a survey. Now, you're not asking everyone the survey, right? So that's going to be a sample. You get the statistics for points scored by Steph Curry based on his last 5 games played. I have no idea what sport this is even talking about, but I do know that this is a sample because it's not all of his games, right? They only took 5. However, I have had people actually try to say that this is a population because it's based on all 5 of his last games, and that a sample could just be 1 out of the 5 last games played. So again, if you're specific in how you choose to explain this, you can get away with some of these. Now, for part D, a gym owner surveys the members who come in to the gym between 4 and 6 p.m. about the classes offered at the gym. I would say that this is a sample because it's only members from certain hours, right? It's not asking like people at 8 o'clock or people, who tend to go to the gym in the morning at like 6 a.m. So you're leaving out a lot of different people here if you were to ask them. And then I think we have one more. You want to count all the fish in the local pond. I would say that's population because it's all the fish in the pond. I've had people try to say that this is a sample because while it might be all fish in the pond, it is not all fish in the world, right? So they're thinking all the bodies of water, and you choose just the sample of one pond. Let's move on to talking about what makes a sample a bad sample, because remember that we use these to make generalizations about the population. So in statistics, it's really important that you have a good sample and that you avoid bad samples, because bad samples means we're going to get the wrong generalizations. Now, a bad sample is a biased sample, where one outcome is more favored than the others, right? It's like if I were to ask my students, do you think that homework is useful? You guys are probably going to say no, right? Because you don't want me to assign homework. You don't like it because you're the ones who have to do it. You are biased because you don't want to do it in the first place. So if I want to get an accurate representation on do I think homework is useful, I'm not just going to ask the kids in my class who I know hate doing homework. Now, an unbiased sample represents the population accurately. It's often the most random sample possible. Another good example of what a bias is if you were to ask the math department, what's the best subject? Obviously, the math department is going to say math. If you were to ask the English department what the best subject is, they're going to say English. So keep in mind that when you're trying to create samples, you want to get a broad generalization of everyone and not just focus in on one type in particular if you know that they're going to answer a certain way. So in our example, we have Ms. Costa wants to know the opinions of students at Central High School regarding the school cafeteria food. She goes down to the cafeteria during period 6 and asks the kids who are sitting in the cafeteria to take a survey about the food. Does this sample represent the population accurately? Now, the answer is no. And I want you guys to try and think of a good reason why, because there's many of them. Now, my initial thought was she didn't ask all lunch periods. She's asking period 6, but I think lunch starts at period 4. Now, I think the way it goes is that when they give out lunch, right, the food that is the most fresh is going to be given to, fourth period. And as you go on throughout the day, as you get towards the later lunch periods, I have students tell me that all the good things go. So period 4 probably likes the cafeteria food a lot more than the last lunch period likes the cafeteria food. Another reason why it doesn't represent the population accurately is because she's only asking people in the cafeteria. But the people who don't like the cafeteria food, they go out, right? They go to, I don't know, Burger King down the street and go eat there instead because they think it's better than being in the cafeteria. So by asking people in the cafeteria if they like the cafeteria food, she's leaving out all these people who definitely do not like it, but they're not there to actually answer her survey. So she needs to come up with a better way to ask these people to figure it out. So again, there are several practice questions. Pause the video, read through them, get the PDF out or print it out, whatever you like. Try to get your own answers and come back to this later to check to make sure you're right. Now, for the first one, we're talking about a small upstate village to determine whether or not local residents should fund construction of a skateboard park by raising taxes. They want to know which segment of the population would provide the most unbiased responses. So we want a general sample, the one that's going to be the most fair to ask. Now, if you're talking about constructing a skateboard park, it's not going to be very fair if you ask skateboard enthusiasts, because obviously they're going to want the skateboard park to be built. You're also not going to ask senior citizens living on fixed incomes. One, because they're on fixed incomes. They don't want their taxes raised because they probably can't afford it, especially for skateboarding. I mean, grandparents don't typically skateboard. If they fall, they break their hip, and that's not good. So, no. A group opposed to any increases in taxes is obviously going to say no to this park if it increases their taxes. So that's biased as well. Everyone you ask there is going to say a certain answer. The most fair is going to be asking every 10th person 18 years of age or older walking down Main Street. Now, I say this is the most fair because this is the most random. And random samples tend to give you good unbiased samples. You're going to have a mix of skateboarders, a mix of senior citizens. Everyone is going to be in there, and you're going to hear a generalization of what they think should happen. And the next one, a survey completed at a large university asked 2,000 students to estimate the average number of hours they spend studying each week. Every 10th student entering the library was surveyed. The data showed that the mean number of hours the students spend studying was 15.7 per week, which characteristic of the survey could create a bias in the results. So think about what's going on. We're talking about people studying each week, and you're asking people who went to the library how much they studied. Now, asking 2,000 students seems like enough of a large enough sample to get a good generalization of what's happening, right? But if you think about it, you're asking people who go to a library how much they study. They're at the library to study. That's why you go to libraries in college, right? Because you want to study for your classes. Of course, they're going to spend a lot of hours studying. If you want a true random sample, you can't ask just the people in the library, because you have the people who are in their dorms who they're not going to study as much, right? All these people outside of the library probably don't spend as much time studying as the people in the libraries. So that number of 15.7 hours per week is kind of ridiculous when you count all the people who don't go to the library at all. So I'm going to say that the method of choosing the students who were surveyed is what created bias. Obviously, people in the library are there to study. That's a bias. Now we have 4 surveys that are described below. They want you to see which methodology would lead to the least biased conclusion. So for our first example, we have 100 randomly chosen heart surgeons were polled by telephone about how to get children to eat healthier foods. Obviously, if you ask heart surgeons about eating healthier foods, they're going to have a certain opinion on that, right? They're all going to tell you to eat the same exact things because, I mean, they're doctors, right? So that's different than if you ask someone random off the street what they might think. They know about this specifically. So I'm going to cross that out. The next one, a country and western radio station asked 100 of its listeners to call a telephone number and answer a question about rap music. Now, a good, perfect example about this is my parents, right? My parents love to listen to country music, and it drives me insane. I hate hearing it. If you ask my parents, who pretty much only at least listen to country music, they are not going to know a single thing about rap music at all, right? So if you know all these people listen to country, why are you asking them about rap music? They're clearly not going to know anything. For choice 4, the first 100 people who left a World of Baseball bookstore replied to a question about the importance of baseball to society. I mean, they're in a baseball bookstore. Of course they think that baseball is important in their life. If you ask me, no. So you can't ask people who clearly like baseball about how important baseball is. That's definitely biased. However, the third option, that should say phone calls. Phone calls made to 100 randomly generated telephone numbers. People replied to a question about television shows they watch. Now, this one is definitely the most random because nowadays pretty much everyone has a phone, right? So you're getting a random assortment of people. And of those random assortment of people, you're asking them about television shows they watch. Pretty much everyone watches television. So random people getting random responses, right? Phone calls have nothing to do with what television shows they watch. So there's definitely no connection there, which means it's pretty unbiased. Choice 4, high school officials wanted to assess the need for a new diving board. They created a survey and distributed it to a large, diverse crowd at the state swim meet held at their school. Which characteristic was most likely to create a bias? Well, you're talking about the need for a new diving board, and you're only asking the swim meet if they need a new diving board. Yes, they're going to want a new diving board. I mean, that's silly. That's like asking a math teacher, does she want more calculators in their class? Yeah, I always want new calculators in my class, right? Because it's important to me. So people at a swim meet are going to want that new diving board. If you ask, a history teacher, if they need a new diving board, he's probably going to say no because it has no use to him. So because there's a connection here between what these people's interests are and what you're asking them about, that's not good. So I'm going to go with choice 4. The way the participants were selected created the bias in this example. Now here's a Regents-free response. It was worth 2 points. We have Chuck's Trucking Company has decided to initiate an Employee of the Month program. To determine the recipient, they put the following sign on the back of the truck. And we have all seen this sign, right? How's my driving? The driver who receives the highest number of positive comments will win the recognition. They want you to create at least one statistical bias in this data collection method. Now, if you think about it, there are so many ways to cheat on this, right? Because you, if you're the driver, can just keep calling in for yourself. Or another point of view is that he can have all of his buddies or family members call for him. So it kind of becomes more of a popularity contest than it does how good are they actually driving. Another bias is that some truck drivers drive in more populated areas, right? Whereas other drivers drive on less populated areas. So if you're driving in an area where there, an urban area where there's so many people going around, you get more exposure, more people might call you. But if you're in more of a rural area, like the countryside, not many people are on those roads. So you're not going to get as many calls. Or whether you are a daytime driver versus a nighttime driver. If you're driving during the day, people can see the sign and call in. However, if you're a nighttime driver, you can't really see the sign in the dark. So how are you going to call? So there's definitely many cases where certain drivers in this scenario would have a leg up on someone else. And if you have more examples, you're probably right, because there are so many different answers to this question. And the last one, which method of collecting data would most likely result in an unbiased random sample? So the first one, you have selecting every third teenager leaving a movie theater to answer a survey about entertainment. Well, movie theaters are a form of entertainment. So there's a connection going on there that's definitely going to be a bias because these people like going to the movies for entertainment. Next one, placing a survey in a local newspaper determined how people voted in the 2004 presidential election. I don't know about you, but I think older generations tend to read newspapers, right? The younger generation tends to get their news online. And the older generation who reads these newspapers, they tend to have a different political view than the younger generation. So there's a bias. If you go on to the next one, selecting students by the last digit of their school ID number to participate in a survey about cafeteria food. The last digit of your ID number has nothing to do with whether you like cafeteria food or not. So this is a possible candidate for an answer because there's no connection going on. If you read the last example, you have a surveying honor students taking Mathematics B to determine the average number of time students in a school spend doing homework each night. Well, you're asking honor students how long they spend doing homework. They probably spend a lot more time doing homework than people in non-honors classes do, right? I mean, they're honor students because they like to, they focus a lot on their schoolwork and a lot of doing their homework to begin with. So I'm going to go with choice 3 because the people you were asking had no connection to what you were asking. And last slide. So those were all examples of bad samples, and the question is, how do you design a good sample? Designing an unbiased random sample, you have to choose participants by impersonal chance, right? So they can't have any relation to what you're asking, like you can't know about that. So we have a representative sample is if a sample is taken for the purpose of generalizing to a population, the sample must be representative of the population. In other words, it must be similar to the population even though it is smaller than the population. So if I want to know how high schoolers feel about school, I'm not going to go to an elementary school and ask how those kids feel, because elementary school doesn't represent high school. So all they're saying is if you're trying to figure out how a certain group of people feel about something, your sample has to accurately represent that group of people that you're trying to find information out about. So your sample has to represent your population. Now, a random sample is a sample whose members are chosen at random from a given population in such a way that the chance of obtaining any particular sample can be computed. All this means is that everyone has a fair shot of being chosen, right? Like if I were to talk about people in the school, I'm not going to choose my first period class because that would give an unfair advantage to them, and as opposed to me choosing randomly from everyone in the school. They need to have a fair, even shot of being chosen in order to avoid bias. There are more specific methods in which to create good samples, but we're not going to go into that for this video. From this video, all you have to know is the difference between a population, everyone, and a sample, a subset of the population. And you have to know what creates a bias. If the people you're asking, the group of people you're asking, definitely feels a particular way about what you're asking about, there's a bias and you want to avoid that. The more random your samples, the less likely you are to have biased results. And that's all for this video.